Notes for section 11.4. We've got a bunch of vocabulary. Starting with a prism. And again, I'm not going to give you enough time to write these all down, but you can pause it. A prism is a polyhedra, and polyhedra is just a fancy name for a three-dimensional shape with many sides. So a prism is a polyhedra with two congruent and parallel faces. They have to be congruent and parallel faces. The bases of that prism are the two congruent and parallel faces. So it has two of these, and they're actually called faces, or they're called bases. The lateral faces, however, are all the other faces. Altitude of a prism is the perpendicular distance between its bases. Perpendicular distance between its bases. A right prism, the lateral edge is perpendicular to both bases. If it's a right prism, the lateral edge is perpendicular to both bases. And the names of some of these prisms are rectangular, triangular, hexagonal, trapezoidal, pentagonal, and then you would say prism. So rectangular prism, triangular prism. Couple things. Let me go back to the right prism. You might be thinking, well, what is it if it's not a right prism? Then it's called an oblique prism. Right prism, the lateral edge is perpendicular to both of the bases. An oblique prism, it's not perpendicular. I didn't put this on the vocabulary really because we're not going to find the surface area and volume of oblique prisms, but you just need to know that there's a difference between the two. All right, so a couple of examples of a prism. This would be a square prism. I don't know if it's easier to see back here or up here, but a square prism, why is it called a square prism? Because it has a square base to it right here and another square on the bottom. Those two bases are perpendicular to the height, and that's also called the altitude. Square prism, triangular prism. I feel like that's super dark. It is. Maybe if I put it up here. Triangular prism has a triangle for the two bases. Hexagonal prism has a hexagon for the two bases. And here's another triangular prism. Octagonal prism has octagon for the base. And what I want to say about them is no matter what kind of prism it is, hexagonal, triangular, square, rectangular, look at the sides of the prisms. Rectangle, rectangle, rectangle all the way around. Rectangle, rectangle, rectangle all the way around. Even on a square prism, you have rectangles all the way around. Unless, of course, your square prism is a perfect cube. Still a prism, but made up of squares all the way around. All right, what are we going to do with those? Talk about its surface area and lateral area. When we're looking for the surface area, you want to add up or have the sum of the areas of the faces. Sum of the areas of the faces. So take all the faces, add them all up, and when it says faces, that includes bases. That includes the top and the bottom of the prism, if you want to call them that. Everything. When you're looking for the lateral area, it's the sum of the areas of the lateral faces only. So again, if we were looking for the surface area of this, if you wanted the surface area, you'd have to get 1, 2, 3, 4 rectangles and 2 squares. 1, 2 squares. If you were looking for the surface area of this, you would need 1, 2, 3, 4, 5, 6 rectangles and 1, 2 hexagons out of that. Lateral area, lateral faces only. You're only doing the rectangles. You wouldn't do the top or the bottom. Let's try it. We've got this rectangular prism, and we're going to find the sum of the surface area. If we're going to find the surface area, we're going to add it all up. So you're basically looking at that saying, all right, I have a bottom rectangle and a top rectangle. And on all of these, we're going to know that they are right prisms. There's perpendicular signs everywhere, but it's not going to be drawn in there every single time. Top rectangle and bottom rectangle would be 10 times 5, area of a rectangle, times 2. There's 2 of those. Plus, you also have a left and a right rectangle. Right rectangle, left rectangle. 6 times 5 are the dimensions of that, times 2. And don't forget, you have a front facing at you and a back rectangle. The front is 10 wide by 6 high, and there are 2 of those. So how do you find surface area? You find every piece. If there's a shortcut, you take it. In other words, saying that there's 2 of each. Add that all up. Calculate it all at once. I don't want you to calculate this, then calculate this, then calculate this. You're typing in 10 times 5 times 2 plus 6 times 5 times 2 plus 10 times 6 times 2 equals 280. I never hold this straight, sorry. 280. And it's meters squared. Try this one on your own. Same thing, rectangular prism. See if you can find all the pieces. Okay, check and see if you did that right. Order doesn't matter. I did the bases first, top and bottom, 5 times 3 times 2. Then the front and back, 8 times 3 times 2. Then the left and right, 5 times 8 times 2, 158 square units. And I know some of you are going to be super tempted to just look at the prism and go 8 times 5 times 2 equals. You got to write it down. These are going to get more complicated, and I need to see your work to know that you have an idea or a clue of what you're doing. Let's try a triangular prism. It's an equilateral triangle. They won't always be. Now, as you think of this, let's go back to the word altitude. The altitude is the perpendicular distance between its bases. What is the altitude of this triangular prism? It's this perpendicular distance. It doesn't have to be height. If you're looking at your prism like this, okay, looking at your prism this way, the height is actually what you might want to call the length. It's the distance between the two. So if you look at this diagram, this is your altitude. This is the height between the two of them. Just because I'm 5'4" almost, 5'3"3/4. Maybe if I stand on my tiptoes, get out of the shadow. Okay. If I lay down, I'm still 5'3" 3/4. Okay. You don't change your height just because of the distance it's going. All right. We're going to find the surface area of this. And first we're going to just kind of decide out what we need. We've got 2 triangles on the front and the back. Plus, we have a rectangle on the bottom, a rectangle on the right, and a rectangle on the left. 3 rectangles. And in this case, because it's an equilateral triangle, all 3 rectangles are the same size. That's not always going to be the case. You won't always be able to just take 3 times one of the rectangles. It depends on what's there. So we have to find the area of these 2 triangles. So we'll start with 2 times the area of a triangle. Area of a triangle, we need to find half base times height. We know half the base is 3.5. Half the base, 3.5. Careful, Make sure your decimal goes way lower than your time sign. The height of that triangle, 30, 60, 90 triangle, we've been working with equilateral triangles. Across from the 60 is 3.5, square root of 3. Half the base times the height, there's 2 of those. One in the front, one in the back. Plus, we need 3 rectangles. How big are the rectangles? 7 by 5 inches. So 3 times 7 times 5, or 5 times 7. Again, you don't type this in separately. You got to get it all in at once. 2 times 3.5 times 3.5, square root 3. Don't forget your parentheses if needed. Plus 3 times 5 times 7 equals 147.4. 147.4 square inches. Another one. What if the triangle isn't equilateral? This triangle isn't equilateral. When finding the surface area, we still have 2 triangles that are the same. The 2 bases. In this case, they're in front and back. So we need 2 of the half base times height. Plus, you also need the rectangles. But the base rectangle is on the bottom. There's one of those. And because it's an isosceles triangle and not an equilateral triangle, these 2 are the same. You can't call that the base, sorry. The bases are the triangles on front and back. So you have 2 triangles, the bottom of this prism, the way it's drawn, the 12 by 8, and the triangle, and the 2 rectangles on the side. Let's start with those, because they're a little bit easier. We can do the 12 by 8. That takes care of the bottom, right here. And then our other sides, we've got 2 of those, and they are 12 by 5. So there are your rectangles, the 3 rectangles going around. We also need the 2 triangles. Let's find the triangle. We need the height, and if you need to, draw your triangle over here and just make a nice normal right triangle so that you're not drawing in. Okay, as I was saying, my computer maybe just glitched or ran out of space because these notes are so long, sorry. Okay, maybe you don't want to draw and work with the triangle in the middle of all that prism and the 3-dimensional stuff. Just draw it off to the side. You know that the base of this triangle is 8. So when we draw a height in there, we cut it in half, we get 4. The hypotenuse is 5. Perhaps you have your Pythagorean triples memorized and you already know that this is a 3. If you don't, then you go with a squared plus b squared, and I'm calling it height right away, equals c squared. And you would do 5 squared minus 4 squared to get it over to the other side. H squared equals 9, and when you square root both sides, you get 3. But as soon as you can start to memorize that 3, 4, 5 is a Pythagorean triple, that's good to know. It's a quick and easy one. So is 5, 12, 13. So now we have half the base. We need 2 of those triangles. Half the base is 4 times the height is 3. Multiply those all together. 2 times 4 times 3 plus 12 times 8 plus 2 times 12 times 5. 240 square feet in that prism. Okay, and lastly we're going with surface area of a cylinder. Surface area is 2 pi r squared plus pi times diameter times height. So a cylinder, why is it 2 pi r squared? Because you have 2 circles, and pi r squared is a circle. Pi times diameter times height will get you this whole distance all the way around. What is the height? The height is the distance between the two circles. So even if it's laying down on its side, this is still its height, the distance between the two circles. Okay, so if we want to find the surface area of this, I'm trying this, as you can tell, I turned a light on. I don't know if that's better or worse. Surface area equals 2 pi r squared plus pi times diameter times height. So 2 times pi times radius, the radius is 3 squared, plus pi times diameter, which would be 6, times the height of the prism, 4. Now we're going to do this two ways. The first way is to get the exact answer. 3 squared is 9. 9 times 2 is 18 pi. Plus 6 times 4 is 24 pi. And that, as a final answer, you would take 18 plus 24, which is 42 pi. That's the exact answer. The approximate answer is, you would multiply that all out. 2 times pi, and you have to use your pi button on the calculator. No more 3.14s in your adult or high school life. Times 3 squared plus pi times 6 times 4 equals, or approximately, 131.9 units squared. You could take 42 times pi, double check your answer. You still get 131.9. Next one, same idea. You're going with 2 times pi times radius. The radius is only 2.5 squared plus pi times diameter of 5 times the height of 8. 2.5 squared times 2 is 12.5 pi plus 40 pi would equal 52.5 pi surface area, which is approximately 164.9 units squared. Let's try the last one. The last one, you're working backwards. Get to use algebra, trying to find a piece of the problem as well as do the geometry. You know the surface area. The answer to your surface area is 592.12. The formula is pi times radius squared, oops, two of them, sorry, 2 pi times radius squared plus pi times diameter of 13 times height. There's our variable. We're trying to find h. But we can't find h by taking this decimal and then doing this as a piece of a decimal, and then this is going to be another decimal, and subtracting this decimal and dividing this decimal. This formula right now that you see is really no different if you had 50 equals 25 plus 6x. You've got an answer, you have a number, even though this number is complicated, plus 6 and a variable. So basically when you're solving this, you would say, what's 50 minus 25? You would get 25 equals 6x, and then you would divide by 6 and get either a fraction or a decimal. That's all we're doing, subtract, divide. So in this one, we do the same thing, subtract, divide. We're going to take 592.12 minus 2 pi times 6.5 squared. Make my times bigger. That will equal 13 pi times h. And remember, pi is a number, it's not a variable. We want to find h, which means we have to divide by 13 pi. Divide by 13 pi. but there's a catch, and that is order of operations. Your calculator knows order of operations all too well. And the order of operations here will take that, subtract, but it knows that it has to do multiply and divide before it does adding and subtracting. So if you type it in like this, it's going to take this number, divide it by 13, multiply that times pi, and then when it's all done, it's going to subtract. So to prevent that, you're going to need a set of parentheses here and a set of parentheses here because we want to divide everything by 13 pi. We don't want to divide just part of it. Type that in. Parentheses. 592.12 minus 2 times pi times 6.5 squared, parentheses, divided by, parentheses, 13 pi, parentheses, equals, height is approximately, if you look at it, 7.9982, which because this was rounded, you know that that probably was supposed to be height of 8. Height equals, but since this was rounded, this is going to also be rounded. Your height is 8.0, and we'll go with units. Height is approximately 8.0 units. If you want, plug height back into your original formula and see if you come up with 592.12. Little tricky on that one, but most of the trick comes in the order of operations.